here's an example of using exchanging in the context of a balance scale. We're given the three pictures above. We're showing that 10 bananas are the same as 2 pineapples. 1 pineapple also balances with 2 bananas and an apple. The question is asking us that 1 apple balances with how many bananas for our third picture. So we've been focusing on using an exchange method for solving these problems, and one of the key ideas for exchanging is you need to make sure that you're trading things of equal value. Okay, so we're looking at our third picture, and we want just apples and bananas on that third scale. So I'm going to go back into my given pictures and see if I can find a scale that has apples and bananas on it already, because that's what we're looking for. So I can tell from this scale that it already has apples and bananas, and what I want to get rid of is this pineapple. So I want to try to make a fair exchange for this pineapple. I'm told in the first picture that 2 pineapples are the same as 10 bananas. So I can reason that 5 bananas would be the same as 1 pineapple, just by cutting the value of each side of the scale in half. So I can tell that 5 bananas can replace 1 pineapple. So I'm going to do that on my second scale. So I will set up the right side of my scale with the given items in the picture. There's 2 bananas and an apple, 2 bananas and an apple. I want to trade out my pineapple for 5 bananas. Get back over there. Stay there. 1, 2, 3, 4, and 5. All right. And that was a fair exchange, because with the information from our first picture, we know that 5 bananas will also balance 1 pineapple. So I made that exchange. I took this pineapple off, and I replaced it with 5 bananas. Now we need to move on to the second idea of exchanging. When we are working with a balance scale, we like to think of a seesaw. And if you take something off of one side of a seesaw, you have to make the same move on the opposite side in order to keep it balanced. Balance scale works in the same way. So if I remove a banana from the right side of my scale, in order to keep the balance, I would have to remove a banana from the left side. And I would continue to do that, remove a banana from the right, remove a banana from the left, and all of a sudden I am left with 1 apple on one side and 3 bananas balancing it on the other side. So the answer to our problem is that 1 apple balances with 3 bananas. And you can slide them up there. So I hope this helps explain our exchanging strategy.